I'd go for the proper title, yeah.
Okay, thanks very much, everybody. Yeah, I can remember the thing wrong. So I'd just like to introduce Neil Bartlett. Neil is going to talk to us today about scaling and orchestrating microservices with OSGi. And I'll let you read his alternate title for yourselves. So microservices is obviously extremely trendy at the moment. Neil works with Paramus. He's a principal consultant, senior developer, and also trainer, many hats, and does training all over the world. He's also founder of B&D Tools, based on B&D from Peter, which is a plugin for Eclipse. Without further ado, I will hand over to Neil.
Thanks very much, Mike. Thank you. Okay, so scaling and orchestrating microservices. So I've hit two really big buzzwords there. I have to warn you, I am going to say the word Docker later on as well, so please try to control yourselves. So these are extremely trendy words at the moment. A little bit of an introduction of why I think OSGi is relevant to this new world of microservices. And this is a slide that I put up at OSGi DevCon in the US. But what I'd like to highlight is, OSGi has been discovering a lot of patterns in software since we started back in 1998. Well, I say we, I wasn't involved with it in 1998. Obviously, some people in the room were, Peter, but OSGi has had services since day one. That is, arguably, that's the main point of OSGi, is to create a service platform. We didn't call them microservices. Microservices was a term that Peter started using in about 2009, 2010. But then some other people came along and started using the word microservices as well. So this is Martin Fowler. And he has written probably, he's written about lots of things, including microservices. He's written an article, the URL is at the bottom, which is probably the canonical reference for what the general industry is currently calling microservices. And so they were talking about that at a conference of software architects in 2011. Okay. The feeling that I get when I hear the word microservices used in this way is this, I kind of get flashbacks to the movie Princess Bride. Don't know if you've seen it, one of my favorite movies. You keep using this word. I don't think it means what you think it means. Or we may have an alternative definition. So this was Peter's blog back in 2010, so 3 years before that. And Peter's reason for introducing the word microservices in OSGi was a reaction to the incorrect interpretation of the word services. At that time, there was a perception that services were a very big and very heavy thing, something that ran on big iron and was very difficult to manage. People were struggling with SOAP and SOA and all these kinds of technologies. And people thought that the same thing applied to OSGi services. But what we're really talking about in OSGi is something very, very lightweight. And so the term was introduced, microservices, and it's called on to a certain degree, but we still, of course, call them OSGi services. So I'm going to try to tie these concepts up in a moment, but if you just have a quick look at how OSGi defines services, this is a very big picture OSGi. I have a service or a microservice. It is published by a provider and is consumed by a consumer over there. And the contract for that service is defined by another bundle at the top there, which I can't reach, called the API bundle. And so this is your classic SOA triangle. You have the contract, you have the register, the lookup, and the consume. But it's SOA going on within a single JVM. Now, if we look at going back to Martin Fowler's article about microservices, so he tried to define this, and obviously it's an evolving term, but his definition is probably the most widely accepted at the moment. And these are the points that he picks out. So, and I've tried to compare these against basically what OSGi services are, and always have been since 1998. So an approach to developing a single application as a suite of small services. Yep, that's what OSGi has been doing all along. Each running in its own process. No. Okay, so that's the only cross on the board that you can see, and we'll come back to this in a second. We don't run OSGi services typically in a separate process. They're in a separate bundle within the same JVM. Communicating with lightweight mechanisms. Yes, very much so. It is the most lightweight possible communication that you can have between two components, is a direct Java in-memory method call. It doesn't add any overhead whatsoever, so that's lightweight. Built around business capabilities. Yes, a bundle is defining a business capability, or at least it should be, and it can be built that way. Independently deployable by fully automated deployment machinery. Yes, we can take a running system and we can independently deploy a new bundle and upgrade to a bundle into that running system. We can build mechanisms around this, and we can independently upgrade the modules of an application without having to upgrade everything at the same time and rebuild everything at the same time. Bare minimum of centralized management of these services. Yes, OSGi is pretty bare minimum to achieve this. Maybe written in different programming languages. Well, I've put a tick with an asterisk because obviously we are still talking about the JVM here. OSGi at the moment is limited to the JVM, and so yes, we can run in different programming languages as long as they are JVM targeting languages such as Java, Scala, Clojure, Frege, etc. And use different data storage technologies. Yeah, there's no limitation on doing this from OSGi bundles. It's quite possible to have one OSGi bundle which is persisting to Mongo database and another to Oracle or whatever. Okay, so let's come back to that mismatch up there, each running its own process. So why does Fowler insist on this being a fundamental characteristic of microservices? The main reason, he states, is that services are independently deployable. And that's to distinguish from monoliths, you know, a big compiled-in monolithic applications. Now, as I think we've shown through the history of OSGi, that's not necessarily the only way to achieve independent deployability, is to separate things into different processes. We do have this capability with bundles. So that doesn't really justify the need for separate processes. You can expect many single service changes to only require that service to be redeployed. Again, we can handle this. We can do this, and we do this all the time. We can upgrade a single module without affecting everything else. More explicit component interface, and then he goes on to talk about how many languages lack the ability to very clearly define an interface. Actually, Java does have the ability to clearly define an interface. It's called interfaces and packages. But of course, in Java, they don't have the service registry. Often, it's only documentation and discipline that prevents clients from breaking components encapsulation. Well, maybe so in a lot of monolithic applications, but in OSGi, we absolutely do prevent the breaking of encapsulation. We will stop you from being able to see classes that you're not supposed to see, internal implementation. So all of these concerns, all of these reasons why Martin Fowler is saying you need to use separate processes for microservices, they all seem to be covered by the existing technology that we have in OSGi. Actually, there are some situations, of course, where we're not covered by the kind of isolation that OSGi provides. So OSGi bundles isolate my code from any other code that happens to be within the framework, except for the packages that I specifically want to import. And so I'm isolated from a lot of problems that I get with the plain old Java class path, you know, the mixing of libraries up into one big messy bag. So OSGi does provide that level of isolation, and it works really well. But of course, I'm not isolated against somebody else in the same JVM crashing or running out of memory or something along those lines. And so it's at that point where, if you want additional level of isolation, such as crash isolation and so on, you need to have separate processes. There was a JSR a long time ago, the isolates JSR. I don't recall the number. It's a fairly low-numbered JSR. 27, thank you. A very low-numbered JSR. It never delivered a final spec because it was very complicated. And they ended up building essentially a whole process management system within the JVM when you've already got the operating system that provides that kind of thing. So you don't get that crash isolation, which you do get with separate OS processes. And then, of course, we've got the very trendy technology, as I mentioned in my introduction, Docker, which provides yet more isolation on top of OS processes. A problem that you get with a lot of OS processes is you can't just give somebody a single executable. That executable will have lots of dynamic libraries, potentially, and config files in strange places, and spit out log files into you don't know where. And so Docker provides a way to package up all of the things that are needed to run a whole application and deliver that as a single image, irrespective of whatever kind of junk happens to be on the machine that you're running it on. It also provides some really nice controls in terms of quotas for CPU, memory, and so on, the usage of the application inside that container. So that's why I've put Docker here on this continuum. Obviously, isolation, stronger isolation as we go over to the right, and the cost of implementing this going vertically. So I've actually put Docker as a little bit lower than plain OS processes in terms of the cost and complexity of implementing it. You get stronger isolation with less effort. But then as you go further and further, you need more isolation. Well, what if you need your application to run on a different version of Linux than the kernel that your base machine is running on? Or if you need a completely different OS, if you need to run a Linux container in a machine that happens to be Windows? Well, you're not going to get that from Docker. You can get that from a full VM. So a full VM as implemented by things like VirtualBox and VMware and so on. Obviously, then, of course, the cost of building these things, the cost of moving these things around the network as well, these things start to get very heavy in terms of size. Docker images can get to, a couple of 100 megabytes, whereas a full VM image, unless you're very, very conservative and careful about how you build that VM image, easily grows up to gigabytes. And then if you have a big data center running lots and lots of instances of a VM, and you're moving around gigabytes all the time, every time you need to upgrade or fix a particular small bug, you have to rebuild a multi-gigabyte VM image and push it out. It starts to get expensive. And of course, it could conceivably happen that something running inside a VM could still crash the entire physical box. It would be difficult, but it could be done. Or, of course, you could just get a power failure, in which case the whole physical box dies. And so you need a separate physical box for your next level of isolation. And then eventually you can have disasters like Hurricane Sandy, which knocked out lots of big data centers on the East Coast in the US. And you need a separate disaster recovery site. So you get more and more isolation. So it's not just a case of you have isolation provided by separate OS processes with microservices the way the industry is talking about them now. You have a big continuum. And OSGi definitely lives on this continuum. And as I think you can see, there are two really nice sweet spots here where you've got a little local minimum. And although the line is a bit wonky, that's because I'm not very good at fitting Bezier curves to points. So you kind of have this progression. If you start with Java and you want to have services in reuse, and of course you do, because how could you possibly develop without those things? You want to use OSGi. If you want to have crash isolation and alternative languages, if you want to write your implementation in Go or in Haskell or in, you get the point, you have to compile in a completely different technology. You can't run that under the JVM. So you can go to a separate process. If you want to add CPU and memory quotas and encapsulation of third-party applications with lots of dynamic library linking going on, then you want to use Docker. And then, of course, if you need an alternate OS, you need to go up to a VM and whole physical boxes for coping with power failures and other serious problems. So that's kind of the continuum, as I see it, of isolation and where OSGi sits in that with relation to microservices. And as I said, we can do a lot of stuff with microservices in OSGi without using separate processes. The title of the talk is Scaling and Orchestrating. So let's talk about scaling. We start with this. It's very easy to horizontally scale microservices as separate processes. Here I have 3 processes talking to each other within a single box. Maybe VM, maybe physical, it doesn't really matter at this point. 3 processes. It's very clear how to scale those. You scale them like this, or you could scale them like this. Right, so you now have a whole CPU per process. When should you do this? So if a developer says, I have this service, should I enable it for remoting? Should I make it a remotely invocable service so that I can scale this in the future? And it's interesting is the agile answer, or the kind of fundamentalist agile answer, would be no. Just almost always, no, you shouldn't do this because you're not going to need it, Yagni, as they say. And it's interesting that it's exactly the same people that used to talk about Yagni and Agile are now talking about microservices, but I guess that's a coincidence. When should I actually do this? Well, if you're using OSGi services, you can do it with a configuration switch. If you want to scale and evolve rapidly from single JVM OSGi applications to multiple JVM separate process microservices, you can do that very, very easily in OSGi now with the remote service admin spec. So you can take a provider publishing a service and a consumer using that service within one JVM, and with a configuration switch, you can go to the provider providing that service across the network and the consumer using it in the same way from another JVM. The services that you enable for this can be selected after they've been developed. It can be entirely oblivious to the developer of the original service. Now there is a little bit of a buyer beware on this coming up, but essentially I can select the services that I want to remote through a simple configuration switch, and I'm going to show how that's done. That means that I can make rapid changes to the whole architecture of my application in order to scale it out to respond to increased demand. And as I said, that sounds a little bit too good to be true. And to be honest, it is too good to be entirely true, because in practice, you do need to bear in mind that some things just can't be remoted. If you design your service interface in a way that it can be remoted, or at least have it in the back of your mind that this thing may be remoted, then you're going to have better luck with doing this when you need to do it. So you should at least factor in that possibility, but it is very much a transparent thing. So I'm going to show a quick demo of that. And I have a workspace here. Do I have to Alt-Tab out? Workspace here. So this is a very simple little application that I actually built for my last talk, which was a B&D tools tutorial. The reason I picked this is because I didn't actually design this thing to be a remoted microservice implementation. It's a service with a consumer, and I appreciate that's too small. We don't really need to see that. I'll show the things that we really need to see in a nice proper font. So what we have is, excuse me, we have a service that provides a blog API. So if I come into the blog API, there is the blog, and that font is ridiculous, isn't it? Text font, oops, 14, 18 probably. Okay. So it's a very simple blog API. I can add an entry to my blog, and I can list the current entries, and they're just plain strings. Obviously not very realistic, but it was developed for a demo. And I have a consumer which accesses the blog and presents the list of blog entries in a web page. Now, I can run this thing standalone, completely standalone. I have a launch definition here, which says, here's a definition. I've got the GoGo shell, I've got the blog consumer, the blog provider, and the Felix HTTP whiteboard, which enables the HTTP service. Yes?
Why is the CNF project not in your Git repository?
Not in my what, sorry?
In your Git repository.
In my shared repository, sorry?
No, in your GIT, in your remote repository.
Remote repository.
You see you're on branch master?
Yeah.
The CNF project is not version.
It probably is. It just I haven't linked it in with JGit. Team share project. Oh. It should be. I don't know why. Just a mistake. Yeah, so I have, here I have the consumer and the provider in the same runtime. So if I click run, I'm going to get up an application. Okay, what? I'll tell you what, I was doing this from the shell before. So bnd run standalone. Okay, so it's running with both the consumer and the provider in the same bundle, in the same OSGi framework, localhost 8080 blog, and you can see it's not a very exciting layout for my blog, but I like to keep things simple. There's the application running standalone. I'm going to shut that down. And we get some kind of spurious errors, but never mind. Now, I'm going to go in and, well, first I'm going to show you what I have here. I have a client.bnd run. So this is another launch definition. In this launch definition, I have most of the same things, but I don't have the provider bundle. So I have the consumer bundle with no provider. So this thing shouldn't work. In fact, if I run it over here, bnd run, client bnd run, that's going to start up. And my web service is giving a 404 because it's not registered the servlet, because there's no blog service behind it. In order to get this working, I want to run the other runtime, which is the server.bnd run. And this is, again, the same, except it's got the blog provider, but with no consumer. So I've got the provider and the consumer in two different runtimes. So come over here, bnd run server. That starts up. Just give it a second just to make sure it sees everything. And I'm expecting this 404, so I'm not going to panic. Yes, there we go, 404, because I didn't make the configuration switch that I talked about. I need to explicitly state that this thing should be remoted, that this blog service should be made remoted. And I do that with OSGi config admin. So come into here, edit this blog.provider.cfg, uncomment the next line. Wow, tiny font, sorry. Service exported interfaces equals star. Save that. And now, give it a second, come on. There we go, okay. So it saw the configuration change, and it published that service, and now the consumer picks up the service that's been published on the network using the RSA Discovery layer, and it connects to it and makes an invocation to the blog service. Okay, so I've taken something that was never designed to be remoted, and it's now remoted, and I can scale this horizontally. And so this is a microservice example. Let's get back to the slides. Orchestration. A problem that you get with orchestrating microservices or actually running these things, is you end up running around like this guy. This is Mike, Mike the headless chicken. This chicken managed to survive for 18 months with no head. It's a real thing that happened back in the 40s. So in order to avoid running around like a headless chicken, you need to know, well, first of all, what should I run? Which things do I need to run? I'm going to have a lot more things to manage now if I have lots of separate processes. Where should I run those things? Some of those things will be platform sensitive, so I can't run a Linux compiled executable on a Windows box, to take a fairly obvious example. And then finally, when all these things are running, well, where the hell is everybody else? How do any of the microservices instances see and connect to the other microservices that are out there on the network? So we need some mechanism of discovery. And local discovery like this is fairly easy. We can do this in many ways, including just writing our locations to a file or something. Remote discovery gets harder, because I have a process over here that wants to talk to another process, and where on earth is it? To be honest, the state of the art in the industry, for a lot of the people implementing microservices, is still install service X on this box, install service Y on this other box, configure X so that it knows where Y is, and configure Y so that it knows where X is. Now, there are some orchestration things coming through, but they're very early days. So I think OSGi can add to this, because OSGi RSA, again, has a very cool and pluggable discovery mechanism that allows us to advertise and discover services on the network without any pre-knowledge of the topology of that network and where things are supposed to be. It's pluggable, it's a standard, so you could implement this based on something like Bonjour, or SLP, or DDS, or some kind of gossip protocol, or Apache Zookeeper. There's many possible implementations of this idea, but it's a nice spec. This gives us dynamic availability and presence. So I know who is on the network, and I know that they're on the network right now because they're advertising their service. If one of these services that we're running crashes, that service will be unpublished, and I know that the service that I want to connect to has gone away, and I won't be able to connect to it. So I will have a choice. I can go and connect to somebody else, see if there's an alternative to connect to, or I can unpublish my own service. This is now a remote service, and say, this application is not working, and we need some operator assistance to get it working again. This means you can do plug and play. You can attach new hardware to your system, run the application, and it just finds all the other services that it needs to run. I'm talking about OSGi services there, and you probably know about OSGi services, for example, the blog service, where it was a Java object, and I was invoking a Java object via its interface. But that's a little bit limited, because not everything can be represented as a service. For example, let's say I have a REST endpoint. This is a REST provider, some bundle over here that's providing a REST service. REST services are not really easily representable by Java interfaces, because a REST interface has a very small number of verbs, fixed parameters, and so on, whereas the Java interface has essentially anything that you could call. At least in my opinion, it doesn't make a lot of sense to directly try to invoke a REST API through a Java object. Although you can build kind of proxies around that, and some of the REST clients, like coming with Jersey and JAX-RS2 and so on, they're looking interesting about building some of these things. But underlying this, you want the HTTP communication, and let's say over here I have a consumer that wants to talk to that REST endpoint using HTTP. Well, how does he know where it is? Well, I can advertise a service. This is a service that doesn't necessarily have any methods. It's an endpoint service. So I advertise a service with a URI attached, which is a string URI, and it's got, when I provide my service, so I provide the service, but I also advertise that I have a service. And I say, I'm serving HTTP on my port, my host address, and my port, and this REST alias. And now the consumer can see this. I could write a declarative services component in here, inject the endpoint into it, pull out the URI, and start talking to it straight away as soon as it comes up. And I can also be notified when the thing goes down. You can also do this for non-Java. So I said, what if it's not a service? Or what if it's not even Java at all? So some technology that we've built at Paramus called the Packager allows us to run OS processes managed by OSGi bundles. This is an open source API that we've implemented. But so we have, as an example, Mosquito, which is an MQTT server. If I say the word IoT, then I think I'll have hit all of the buzzwords for this week. So it's an MQTT server, and it's a native process. It's written in C. Thank you. I'm going to have to speed up. It's a C process. We manage that from OSGi. We declare the fact that we have an MQTT server with the MQTT URI scheme, and the consumer connects. In my demo, I used Paho to connect to that directly via MQTT. So that works for non-Java processes, non-Java services. We can also have non-Java consumers. So if we have multiple HTTP backends, a common load balancer for HTTP is Nginx, again, a native process. And we can reconfigure Nginx every time one of these backend services goes up and down, so the load balancer always knows about the current state of working services that it can forward to. And by the way, as I said, I'm going to say the Docker word, the D word. We can have these processes implemented as Docker containers, again, publishing their existence. So Mosquito, this time inside a Docker container, publishing an MQTT endpoint, being used by a consumer. And this is actually what's running on the very popular OSGi IoT stand downstairs. There's my colleague Venelin has got a Raspberry Pi. So the Raspberry Pi is discovering the back-end services in the cloud that it needs to talk to. So you can plug in your Raspberry Pi, it sees what it needs to connect to, and starts working. Yeah, I'm going to have to skip that to save time, so I can show you my demo. So the demo is here. Right. There's 9. While that's coming up, what I wanted to say is what we're using for this is the OSGi capabilities and requirements, metadata that describe what the software is and what it requires to run. It's an OSGi idea, but it's very, very powerful and it doesn't necessarily apply only to OSGi bundles. We can use it to describe even things like Docker images. And why is that not working? OK. So quickly import this system. So I'm importing a system which needs to have two managed components, two parts. And it seems to be going rather slowly. Is this the network?
It's a bad day for live demos.
It is, yeah. At least my screen is working. That's not been always the case. So what I was going to show you, I have a definition of some software which has got two parts, defined as a bookshelf service and a site that manages all of my bookshelves. That was a REST service, and it was connecting to that, and I would have multiple implementations. As I fired up more nodes, the bookshelf would see all those implementations and show them all to you on a web page. And it would also scale out and push the software out to all of the nodes that were joining the fabric and I'm just getting nothing here. It's, sorry? Well, I'll tell you what I can do. Oh, did the network change while the flipping fiber was up? Excuse my French. Okay, I've run out of time to do this demo. I would like to show it to you if anybody's interested, but please ask me to do that. Hold on, kill that. Try to keep it going. Okay, so just to sum up, what we talked about was I've shown some of our company's technology. It's not really intended as a sales pitch, but what I'm talking about is OSGi. OSGi Remote Services, I used our implementation, but that's an OSGi specification. The Packager stuff to wrap up the native processes and the Docker images, open source API. The Paramount Service Fabric, which regrettably I didn't get to work, is our secret sauce, which is about like managing how many instances of these things to say where they're placed and so on, to make sure that all the things that are supposed to be running are actually running, but it doesn't like the network. And thank you, and any questions, and I apologize for the rush and the errors.
Any questions? So thank you very much, and thank you, Neil. We're a little bit tight on time, so if anyone does have any questions, if you could grab Neil in the corridor outside, that'd be much appreciated.
Thanks, sorry, mate. I need to get out, don't I?